Welcome back. I am Assistant Professor Milan Patel, ME Electrical Power System from the Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we will discuss AC armature winding from the chapter number 3, Subject Elements of Electrical Design, having a subject code 31609118. Now today's flow of contents are basics of AC armature winding, terminologies related to the AC armature winding. Now, from this video lecture, we will cover these 4 questions A, B, C, D, which was asked in previous GTU examination. So, first question is, with suitable diagram, explain the terms with respect to AC armature winding. First one is phase spread, corded winding, coil span, full pitch coil was asked in summer 2016 for 4 marks. Now next question is, write a short note on types of AC armature windings, which was asked in summer 2017 for the 4 marks. Now third question is, discuss the advantages and disadvantages of the short pitch winding, was asked in summer 2017 for the 3 marks. What is fractional slot winding? Discuss its advantages, was asked in June 2011 for the 3 marks. Today we will discuss AC armature winding. In AC machine, the stator has AC armature winding in which the alternating EMF is induced. So the winding for armature of a DC machine is closed, and the closed winding are always double layer type. So the winding used for AC machine are open. Okay, so in AC armature winding, closed open type AC winding is used because it is a double layer type. So in AC armature winding, double layer type open winding are used. The open winding may be single or double layer type. The stator winding consists of singleton or multi-ton coils arranged in slot and connected properly so as to obtain the required phase grouping. We know that in AC there are number of phases are there, so we have to take care for the phase grouping. In each phase and frequency must be same for AC winding. The EMFs of all the M phases of AC machine must have identical wave shape and displaced in time phase by 2 pi by M. So one condition is therefore in AC armature winding, in each phase EMF and frequency must be same. EMF and frequency must be same, and for m number of phases the phase displacement is given by 2 pi by m, 2 pi by m, where pi is equal to 180 degree. In AC machine, the wave shape of the generated EMF depends upon the flux distribution in the air gap of the machine. So the generated EMF wave shape will be depend on the given flux in the air gap. So air gap flux is main reason for the shape of the generated EMF. In AC winding, the ends of the first coil and the last coil, or the beginning of the first coil and the ending of the last coil, is kept open. So this is known as open coil winding. So in figure we can see that the ends of the first coil, and last coil, or the beginning of the first coil and the ending of the last coil is kept open. We can see in this figure this one and this one. This is the beginning of the first coil, this is the ending of the last coil, is kept open. So this is known as open coil winding. So now number of phases and phase spread. The basic requirements of AC windings are that it should generate a symmetrical M phase system of EMFs of equal magnitude, frequency, and identical wave shape. So, for number of phases, it must be required that the same magnitude of the voltage and the same frequency, and last one is identical wave shape. So all the M phases have the same wave shape. Also, the EMFs of the various phases should be displaced in time phase by a beta is equal to 2 pi by m electrical radians. So this is the equation of the phase spread for the m number of phases. Suppose we consider 3 phase, then the value of m is equal to 3 and 2 pi by 3 is equal to 120 degree. The answer will be 2 pi by 3 is equal to 120 degree. So consider 12 slots, 2 pole 3 phase AC winding. Consider 12 slots, 2 pole 3 phase AC winding. So pole pitch is equal to number of slots per pole. We know the equation for the pole pitch is given by slots per pole. So slots is equal to total slots is equal to 12 and the number of poles is equal to 2. So our answer will be 6 slots under the one pole. 6 slot pole pitch mean 6 slot under one pole and another 6 pole is under next pole. So slot pitch alpha is equal to pi p by s. Slot pitch is denoted by alpha and pole pitch is denoted by tau p. So it is given by pi p upon s. Pi p divided by s. So here pi multiplied by p is equal to 2 divided by number of slots is equal to 12. So our answer will be like this, pi by 6. 2 and 2 cancel out. So pi by 6 is equal to 30 degree electrical. Now the phase spread is given by beta is equal to 2 pi by m, 2 pi divided by m. Here 3 phase is given, so 2 pi divided by 3. So our answer will be 120 degree electrical. So these all are the parameters required for the above given data. So now this is the 3 phase winding of 60 phase spread, 60 degree phase spread. So this is the arrangement of slots. So this is the teeth, this is slot, teeth, slot, teeth, slot arrangement. Here total number of 12 slots are given. Here total number of 12 slots are given. So I drew 12 slots in this figure. 1 2 3 4 5 6 7 8 9 10 11 12. And first of all, I consider 60 degree of phase spread. 60 degree of phase spread. So slot pitch is 30 degree. So each slot is displaced by 30 degree. Each slot is displaced by 30 degree. Here we consider 60 degree phase spread. So in one phase spread, two slots are there. Two slots are there here. For 60 degree interval, slot number 1 and 2 are there. Another 60 degree 3 and 4 are there. Next 5 and 6. So phase spread beta, this is the phase spread beta, because this is a 60 plus 60 120 degree. So this is the phase spread beta. Slot pitch 30 degree. Distance between two adjacent slots is given by 30 degree slot pitch. So first slot 1 and 2 is considered for the phase R. Phase R. And we know that in a three-phase system, each phase is displaced by 120 degree. So after 120 degree, the phase B will be there. After 120 degree, phase B will be there. So this is 60, 60 R. So sorry, here we consider 60 degree of phase spread. That's why after 60 degree RYB is there. So this is the 60 degree of R phase. After 60 degree Y is there, and after 60 degree of Y phase, B phase is there. R, Y, B. R 60 degree, Y 60 degree, B. Same for B dash, R dash and Y dash. We know that each R and R dash is 180 degree apart, Y and Y dash is 180 degree apart, B and B dash is also 120 degree apart. So this is the actual mechanical arrangement of the slots for the three-phase winding 60 degree phase spread. From we can see that conductors for phase R are placed in slot 1 and 2 and 7 and 8. So R phase is placed in slot number 1 and 2 and 7 and 8. Same for B phase, Y phase 5, 6, 11, 12. For B phase 9, 10, 3, 4. So for one phase spread is 30 into 2. So phase spread is 60 degree, 30 multiplied by 2. Now phasor diagram for the arrangement, for this arrangement, for the 60 degree of interval. So now the EMF induced in R phase is given by this phasor diagram. So first of all, slot number 1 contain the conductor number 1. So it will generate E1 EMF. E1 EMF. E2 will generate, conductor 2 will generate E2 EMF. So this conductor will generate this E1, this conductor will generate this E2, this 7 number conductor will generate this one, and 8 will generate this E8. Here given sign is negative because they are in phase group of R dash, means the opposite of the R. Opposite of the R. So this phase displacement is given by 30 degree because they each are placed at the 30 degree. That's why the each phase is at the 30 degree. E1 and E2 is at 30 degree. E7 and E8 is also at 30 degree. So resultant phase ER is given by this. ER is given like this, and this is the resultant of E1, E2, E7, E8. But E7 and E8 is considered negative. So same for Y phase and B phase is there. So this is the phasor diagram of the particular system. Now copper utilization is better by 11.5% in an AC winding with 60 degree phase spread compared to the 120 degree phase spread. So it is more commonly used. So when we will use 120 degree of phase spread, 120 degree of phase spread, then 11.5% of copper will be used more. So it is better to use 60 degree phase spread in three-phase winding. So this is the arrangement for the three-phase winding for the 120 degree of phase spread. So in 120 degree phase spread, there are 1, 2, 3, 4 slots are there. 4 slots are there. So 1, 2, 3, 4 number of slots are for the R phase, 5, 6, 7, 8, 9 for the Y phase, 10, 11, 12 for the 1, 2, 3, 4 for the R, 5, 6, 7, 8 for the Y, 9, 10, 11, 12 for the B phase. So this is the 120 degree phase spread arrangement, but it will consume more copper than the 60 degree of phase spread. Now important definitions for the AC armature winding. So first definition is coil spun. First definition is coil spun. The distance between the two coil sides of coil is called coil span. So this is the basic. The distance between two coil sides or conductor for the same coil is called coil span. Suppose this is one coil, then the distance between this line, straight line, and this dotted line is called coil span. Now full pitched winding. full pitch winding. Most IMP definition, full pitch winding. The coil having span which is equal to one pole pitch, means tau p, is called full pitch winding. So when the coil span is equal to the pole pitch, then the winding is called full pitch winding. For 12 slot 2 pole 3 phase AC armature winding, pole pitch is given by number of slots per pole. So 12 divided by 2 is equal to 6. 12 divided by 2 is equal to 6. So in figure we can see that suppose our first conductor is placed in the slot number 1, and another conductor of this coil is placed at the slot number 6, then it is the 180-degree phase spread. Then it is a 180 degree of phase spread. So it will called full pitch coil, because in this coil full pitch is used of 6 slot, because pole pitch is 6 slot and here full pole pitch is used. That's why it is called full pitched coil. Now the next definition is for the short pitch or corded winding. Short pitch and another name is corded winding. When the coil span is less than the pole pitch or less than 180-degree electrical, then the winding is called short pitch or corded winding. So when the coil span is less than this pole pitch, then or less than 180-degree electrical or less than 180 electrical degree, then the winding is called short pitch or corded winding. So if we put another conductor of this coil at the 5 number slot, then it will called short pitch winding, because we have used uh, less than the pole pitch or shorter than the pole pitch. That's why it is called short pitch winding. Now advantage of the short pitch winding. Advantages of the short pitch winding. First one is amount of copper used is less in the overhang. Amount of the copper, so we can simply see that in full pitch the overhang copper will be used more, and in short pitch overhang copper will be used less. Harmonics can be reduced or totally eliminated. Harmonics can be reduced or totally eliminated through this type of arrangement. Due to less harmonic, eddy currents and hysteresis losses are also reduced. Due to less harmonics, eddy currents and hysteresis losses can be minimized. And last one is efficiency will increase due to the decrease in the losses. Efficiency will increase due to decrease in the losses. Now the disadvantage is total voltage around the coil is reduced. Total voltage around the coil is reduced because the shorter arrangement of the conductors. Now next definition is integral slot winding. Integral slot winding, when the number of slots per pole per phase is equal to an integer, then it is called integral slot winding. So simple, the slots are divided by the pole and phase, pole multiplied by phase, then it is called integral slot winding. Integral slot winding. So divided by the slot per pole per phase is an integer, then it is integral slot winding. And fractional slot winding, when the number of slots per pole and also the number of slots per pole per phase is not an integer, then the winding is called fractional slot winding. So we can also say that when the winding is not integral slot winding, then it is called fractional slot winding. Fractional slot winding.